All right, let's continue on then. This is part 2 of this tutorial, and you'll notice there are 3 major things on the bottom of the first page here: exception handling, inheritance and abstraction, interfaces. I don't know what that is, but imagine it's there. All right. Then nested classes, regular expressions, generics, enumerated types, I/O, and serialization. Again, this is meant to be an introduction to this stuff. All right? So, once you've created an object, what can you do with it? You can overload its methods. You can override its methods. You can compare objects one to another. You can use class variables and class methods. Please look up on the screen here if you would. If you do, you'll notice that there are 2 different methods that have the same name. They're both called print audit. The first one requires that you pass in what's called a string builder. The second one requires that you pass in what's called a logger. Everybody see these? They're exactly the same. This line here and this line here are exactly the same, except for what's inside of the parens. All right. Now, you might say that's who cares. It becomes a very important thing because I can do stuff like this. And you've seen examples like this. I can say public int add 2, int n1, int n2, return n1 plus n2. You've seen stuff like this before. But then I can go, and right underneath that, I can have another one, and this can be a double, and a double, and a double. The point is, these are now overloaded methods. There are 2 methods with the same name, but what goes inside, the parameters that are inside, are different. I could even do this again. It would start to get confusing here, but I could even do this. That's legal. Because the first time they're both ints, the second time they're both doubles, the third time you've got a double and an int. I could do it again and say here, string. All right, so that is one method that has been overloaded a total of 4 times. Does that make sense? So what goes in the parentheses must be different. All right. So you can overload a method just by changing. You can't overload a method just by changing its return type. Look at that. What that means is I cannot do this. All right, I've got this one here, and I can't, for example, come in here and do this and say long. Because why? Because what's in the parentheses is still the same. Make sense? And you're going to see overloaded methods all over the place. You can't have 2 same name methods with the same parameter list. We just said that. All right? Those are overloading. Here's overriding. I create a person. All right? So I create a class called person. Then I create another class that's called employee. All right? Look on the screen, please. These are all words you're going to have to learn sooner, not later. This word here, extends, means that a person is a child, an employee is a child of a person. So an employee is a type of person. An employee class, in this case, inherits from a person class. If the person class had something that was written, figure out pay. That's actually the best one, because I think you would all agree with this, that if I write something like this, we're actually going to look at something sort of similar to this. So if I go in here and I write this, and I say, so this is an employee, and I say all employees, I'm going to write a method that they're all going to share. And it's not going to be called speak, it's going to be called earn pay. Now, I've got an hourly employee, I've got a commission employee, and I've got a piece worker employee. Would you agree that probably all of those people earn money in a different way? Does that make sense? All right. So I can take that method that's called earn pay here, and I can rewrite it differently here, and here, and here. Maybe under hourly, I've got a full-time hourly and a part-time hourly. And maybe their pay is done differently. So I can keep going down and going down and going down and overriding it whenever I want to. If I don't want to override it, so if I don't want to let this be overridden, let's say when I get to here, I don't want that to be overridden. Then when I create it, I put the word final in there. And you also use final when you create constants. We don't use const. We use the word final. All right?
So extends is just like the colon?
Yes, exactly. Extends is the colon that we used in, very well put, in C#. And just like C#, Java only allows single inheritance. You can have only one parent. But what you can have in here are multiple interfaces. We looked a little bit at interfaces with the C# class. We're going to look a lot at them in Java. All right. It says here 2 ways to compare objects. Okay? So what if I do this? What if I go in and I create 2 objects? Oops, well, that wasn't good. I shouldn't have erased that. All right, I come in here and I say person Mike equals new person. Okay? And then I say that, the first name is Mike, the last name is Smith, the height is 70, the weight is 200, the gender is male. All right? Now, I create another person. And let's just say I call them Michael. And I say equal new person. And I put the exact same stuff in here. I've got 2 Mike Smiths at this, whatever it is, if it's a gym or whatever. So Smith, 70, 200, and male. If I come through here and I say if Mike equal Michael. Look at that on the screen or on the board. Is that true or false? And why?
True.
Why?
All the same information.
Okay. It's false almost for what you just mentioned. Because when I create this one right here, somewhere in memory, I don't know where, but let's say over here, it puts all that information. Would you agree? And when I create this one, somewhere in memory, maybe over here, it puts all this information. Does that make sense to everybody? When you check to see if one object is equal to the other, what that says is do they both point to the same area in memory? It has nothing to do with their contents. Do they point to the same area in memory? If you want to know if the objects are equal to one another, you would use the equals method. And you would typically write your own where you'd compare the values inside of each thing. So I'd compare the first names, then the last names, then the heights, then the weights, then the genders. Since they're the same, yes, they're equal. Make sense? Now, like I said, hopefully Charles has to write that password back up there again. He'll write that password back up there again. All right. And again, they show you how to do that in here, where you'd be doing a compare. There you go. One thing that we're going to be doing that you never ever did in C#. Do you remember in C#, a lot of times if we'd print something out, we would print something and then at the end we'd oftentimes say something like the name of a variable dot toString. Okay? Which said if the variable held 37, now it's not 37, it's the string 37. One thing that you can do in Java is you can take the whole toString method and overwrite it to make it do whatever it is you want it to do. We're going to see some of that very shortly. All right. If you look up on the screen here, what I want you to get, if you look at the top of the screen, what I want you to understand, I said it before, I'm saying it again. If you use the word static, like we have here, there's only one. And no matter how many objects you make, they all share that. If you don't use the word static, they each get their own. And it's important that you understand that. But I always love this. I've got a new subscriber, Yosef Samir. My last 15 or so subscribers to the YouTube channel have not had English names, and I've never heard of any of them. All right. Does this look familiar? Constants, all in uppercase. All right. You either run it together or you separate it with underscores. But here you use it as you put the word in final. And also typically you make them public. All right. All right, next thing, if you look up on the screen here, we talked about this again in the C# class a little bit. We're going to talk about it in more depth. You are going to write these in a couple weeks. Exceptions. All right. Remember, an exception is an exception to the norm or an exception to the rule. An exception in programming is not a good thing. All right. It means that something happened that shouldn't have happened. All right. They give an example here. It's not important. The point is, you can have exceptions for a lot of reasons. We will be using this type of way or thing to set up exceptions. And again, it's similar to what we've looked at in the past. You have a try block. Inside of that try block, you'll put in one or more lines of code that conceivably could error out. Then you can catch any exception you want in a catch block, and there's something that's called finally. Again, please, if you would, look up on the screen here. I want to make sure you all hear this. In the try block, you put the code in here that could conceivably fail, whatever it is. All right? Then you can have as many of these catch blocks as you want to or need to have. The most general ones go at the bottom, the most specific ones go at the top. All right? And then at the end, if you want to, you can have finally. The key thing with finally is regardless of whether the try works and you skip the catch or the try fails and you do a catch, you always run the finally block. So finally is typically used to close a database connection or to close a file. some kind of a housekeeping operation. Java has two kinds of exceptions: checked exceptions and unchecked exceptions. All right? When a program causes an exception, it throws an exception. Notice that checked exceptions are checked by the compiler, as it says, meaning the compiler makes sure they get handled in your code. Unchecked are not checked by the compiler. With most of these, with like unchecked exceptions, they're things like you ran out of memory. They're not things that are within your control. You typically can't program for that. I can't write a program that's going to say, hey, if we run out of memory, do this. All right, usually at least, I cannot do something like that. There's the multiple catch blocks shown on the page here. All right. The application entry point, talked about this already. You're going to write 3 programs starting today. Each one of them is only going to have a main. Everybody hear that? All the code will be done inside of main. All right, and then it's either tomorrow or Wednesday, I don't remember. You're going to take and grab each one of the things that you've been doing and put it in its own method, and main will become a driver. You've heard this before. Not only that, all right, eventually you're going to have at least 2 files. Everybody hear me? One file will be called, like if we have 2 payroll files, one will be called payroll.java, the other one will be called payroll.driver.java. And that driver, all it'll have in it is a main. All right, we're going to get to that point by next week. We've talked a little bit about inheritance already. All right, and Evan, was correct when he talked about extends is like the colon that we had in C#. All right, and again, you can only extend one class. So either you extend nothing or you extend one class. Because Java supports single inheritance, it does not support multiple inheritance. All right, looking on the screen here, we saw this before, but that is an example of a constructor. In fact, if you look up on the screen at the thing in the gray on the top of the screen, that's a special kind of constructor. This is not a trick question. How many arguments are in here? How many arguments are in there? All right, that's called a no-arg constructor. When we run our first Java programs that we write today, we're not going to have a constructor. Did you all hear me? So Java writes one for you. What does it do, Jeff? Nothing. But it needs a constructor. So it writes one for you automatically that does nothing. And if it writes one for you automatically that does nothing, it's a no-arg constructor. But constructors can also be used to initialize things. We're going to do that by the end of the week. If a child wants to call a parent's method, did you hear me? If a child class wants to call something that's in the parent class, specific to the parent class, it can use the word super. All right, that's one of the key words when I showed you the list of keywords before. Talked about no-arg constructors already. Please look on the screen. Again, I'm trying to hit you with what I consider to be, for right now, the most important things for you to at least be exposed to. These are the 4 different types of accesses that you have in Java. You should know already what public is. You should know already what private is. You may or may not know what protected and package private or default are. They're shown here on page 24. This is new. Look up on the screen, please. In Java, you can have abstract classes and you can have an abstract method. You look up on the board there. Remember we had that employee? Remember before that employee we had animal, and under animal we had dog, cat, and pig? You'd never create a class called animal. It's too general in nature. Would you tell somebody, I just bought a new animal? Doesn't really make a lot of sense. So if you're creating a class so that other classes can extend it, and you put a lot of very general information in it, that's an abstract class. Any class can be abstract, but an abstract class, you cannot use the new operator with it. In other words, it cannot be instantiated. It can't have any regular code in it. What? Well, you'll see it in a minute. And if you've got an abstract method in the class itself must be called abstract. So please look again up on the screen at the top of the page. Notice public abstract class employee extends person. See that underneath it where it says public abstract Boolean validate? Everybody see this? That means that anything that's going to use this class must have a validate method in it, and that validate method must return true or false. You're going to be using this very shortly. Interfaces. How many, when we talked just a minute ago about inheritance, I said a Java class can inherit either 0 classes or 1 class. Everybody remembers that, right? But it can also, rather than inherit, it can do what's called implement as many interfaces as you want it to implement. So what's the difference between a class and an interface? The main difference is that a class says public class followed by the class name. An interface says public interface followed by the name of the interface. Typically, you put a lot of code in a class. You put little to no code in an interface. And again, you will be writing these. So you extend for inheritance, you implement for an interface. So you could actually have a class that looked like this. You could write, for example, public class C1. C1 extends, that's a little e, extends C2 implements, and usually when you write interfaces, you start them with the letter I. I1, comma, I2, comma, I3. Now this isn't that important, except what I want you to get out of this is Java supports single inheritance but multiple interfaces. So you can have 0 or 1 classes you inherit from. You can have 0, 1, or more interfaces that you implement. All right. Remember regular expressions? Remember those? All right. Java supports regular expressions just like JavaScript does, just like C# does. I'm not going to run through anything with regular expressions right now, but it's a way to do pattern matching. Java supports tons of stuff with strings. Again, if you would please look up on the screen here rather. I'm going to come in here and under packages, I'm going to see, is there a Java dot color event? We'll just run through this later. All right. But Java has a whole ton in their string class. In fact, we could do it. I could do it like that. All right. If you look up on the screen here, there's the Java string class string. Look at this. See this where it says those are all the constructors. Now method summary. All right. If you look here. Those are basically all the different things you can do with strings. All right, a lot. Bless you. Generics, we're going to cover a whole lesson on those. It's a kind of a hard topic, but it's sort of a way for you to, for lack of better words, kind of create your own variables. All right. You know what enums are already. We've talked about those in other languages. And when you create an enumeration, you're creating your own variable type. So often used for, like, I could create an enumeration that would be called directions. And I could make east, south, north, west, etc. Java allows you to work with files. Java allows you to work with databases. Hoping we can do some stuff with databases this semester. All right, but it's got a lot of good file support. That's pretty much it for this one. Okay. So if you do get the time, just take a look at what's in there. All right. So let me stop this. Is that one still running? Yeah, it is. That's all right. I'll just keep going then. All right. I'm going to jump in then to right here, this Java trail. You look up on the screen. The plan is today, and it won't take that long, maybe a half an hour or so. I don't know. We're going to go over this. Right there. We're going to go over that. All right? And it's object-oriented programming concepts. You know most of this stuff already, so we should be able to go through it fairly quickly. All right? Tomorrow, we'll go through this. And it may not look like it, but this is really big. This is very big and very long. The good news is you know most of this stuff, everybody in here. Because what we go over tomorrow will be things like operators, you know, like relational operators, arithmetic operators, etc. All right, but let's just jump into here, this object-oriented programming concepts. What is an object? All right. An object is an instance of a class. What is a class? It's a blueprint from which you create objects. What is inheritance? It allows you to go and grab, you know, and take a class and have a class get things from another class and override anything it wants to override. What's an interface? Somebody tell me this. What does API stand for? How about the A? What does the A stand for? Yes. What does the P stand for? And what does the I stand for? No. It's on the screen. Interface. An interface that you create, like an API, is a contract you put into your program so that other people are able to use it. So they go on in here, and again, I don't want to waste any more of our time, but if you take a quick look at what's in here, real-world objects share two characteristics. They have a state and they have a behavior. So in other words, if you create an object, the reason for you creating an object should be because it's going to do something. Does that make sense? If it's not going to do anything, why are you creating it? All right, they use a dog for an example. It says a dog has a state. At any one time, it has a name, a breed, it has a color, it has a weight, it has a length. All right, it also has behaviors. It can bark, it can fetch, it can wag its tail, it can bite, etc. So any object that you create, each object has its own state and its own behavior. So as it says, software objects are similar to real-world objects. They consist of state and related behavior. An object stores its state in fields or variables, and it exposes its behavior through functions, which we normally call methods. Here's a question for you. And you may say, I don't know. Yes, you do, because we went over this last semester. All right. What's the difference between a function and a method? You're making it too hard. The difference between a function and a method is all a method is it's a function that's been written inside of a class. A method is a function that's been written as part of a class. Building code into individual software objects provides benefits like modularity, information hiding, code reuse, and pluggability. Look at these. The main reason you build a class is so people can create objects of that class. That should make sense. All right? And you can set up an object that if you implement it correctly, other people can use it and they don't have to know how it works. You guys remember I did this for you in the past. I even did it for the first year people this morning. You can bring up the calculator on your computer. You type in a number. You hit the square root key. What do you get? The square root of that number, correct? All right. Do you know how the computer internally changes that number into the square root of the number? Do you know how that's done? I have no clue. I don't care. I just care that if I put in a number, it gives me the square root. But how that's done is hidden from me. So a class, again, a class is a blueprint from which you can make objects. All right? Look on the screen, please. All right? Notice we've got here class bicycle. All right? Would you agree that if you looked at all the bicycles in the world, the number of gears that each bike has would be different? Not that each bike, but I can get a 10-speed, I can get a 5-speed, I can get a no-speed, etc. All right? So the stuff that you see right here, these variables right there, those are instance variables. Just like before when we did this. If I come through here and I say this, all right, looking on the screen here, if you would, I just quickly dummied this up. Would everybody agree? Let's say these are people who are going to be in a gym. All right, and if you want to join the gym, I need your name, your height, your weight, and your gender. We'll make that a string as well. Would you agree As an example, I could have two people named Jeff Scott. Wouldn't that be possible? The chances of me having two people named Jeff Scott with the exact same height and the exact same weight, it could happen. It probably wouldn't happen, but it could happen. All right. Inheritance. Different kinds of objects have a certain amount in common with one another. So look on the screen if you would. Look at the picture here. All right. We've got bicycle, we've got mountain bike, road bike, and tandem bike. Everybody see this on the screen? All right. What does bi mean? Two. So we're supposing here that a mountain bike, a road bike, and a tandem bike all have two wheels. Wouldn't that seem like a viable assumption? All right. There could be different kinds of mountain bikes. Would you agree with that? So we could go down further in the hierarchy here. So we've got bicycle up there that we already set up. Mountain bike extends bicycle. Again, meaning inheritance. And I can grab everything that was public, I can use automatically in the child. All right. What's an interface? We already talked a little bit about this. It says objects define their interaction with the outside world through the methods that they expose. Methods from the object's interface with the outside world. What is this? You know, again, you've seen this before. All right? If I said to you, what is that? It's a calculator. I agree with you. But more than that, it's a calculator interface. It's your picture of what a calculator looks like. In fact, if you notice here, we've got standard, and if I change this to a scientific, would you agree it looks a lot different now? I have changed the interface. But whether I do this, and I say 12 times 3 equals, and I get 36, or I put it back to this, and I say 12 times 3 equals, the implementation is still the same. It's just the interface that changed between the two of them. A package, I already mentioned this to you, as it says, a package is a namespace. It's like the using statement. You can think of packages, it says here, as being similar to different folders on your computer. All right? You will be responsible, if you look up on the screen here, for answering these questions. All I picked from here, I didn't pick the exercises, I just picked the questions. So real world objects contain what, for example? A state and a behavior. All right? Type of thing. So you can go through here. I mean, you could just sit there and click to check your answers, but you're not going to really learn anything if you do that. All right? All right, let me stop this. Did this finish yet? No, it's almost done though.